Hello, this is the severe weather chapter, chapter 11, and I am going to launch it right here. Chapter 11, severe weather, lightning, thunder, and tornadoes. This is just a great chapter that combines so many of the things we've talked about over the whole entire semester. It's the culmination of almost everything we've talked about. I'm going to try to go through as quick as I can and maybe do this in 2 segments. Just knowing the length of the chapter and how many slides, and hopefully I'll help you pick out some of the themes that you should be for the chapter. To understand severe weather, you got to understand thunderstorms. Thunderstorms are the ultimate expression, in particular in the Midwest and the mid-latitudes where we live, of the ability of the atmosphere to produce powerful weather systems. Of all the things that are the centerpiece of severe weather is that of thunderstorms, and we're going to look at the geography of thunderstorms. But before we look at that and tornado development and how thunderstorms all tie into it, we want to first understand one of the most visual expressions of thunderstorms is that of lightning. And lightning, to me, of all the great things and we could talk about, is the great history, talking about the Greek gods like Zeus and the power of lightning. It has to have been one of the great mysteries that man has always been questioning about. Where does the energy come from? How does the atmosphere produce it? When you think of the great Greek mythology and the gods like Zeus, and Zeus using the power of lightning as one of the great powers of nature, it's obviously not a topic that is new. It's been something that we've been asking quite a bit. In science, it gets to be more fundamentals. We look at basically the inside of a cloud, and we understand how clouds become electrically active is by charge separation. Charge separation occurs when we look at the atmosphere and we see a vertically developed cumulonimbus cloud, and as water moves up and down drafts, as we will talk about and with thunderstorms, these up and down drafts have major effects producing friction. So as ice crystals move up, lighter ones and heavier ice crystals come down, they rub by one another, and massive amounts of static electricity is generated through friction, and basically electrons are rubbed off on the heavier ice crystals moving down, and they begin to pick up those electrons and get a negative charge. And the top of the cloud, where the updrafts take the lighter ice crystals, they lose their electrons and have a net positive charge. So over time, we see a thunderstorm building where the top of the cloud is positively charged and the bottom of the cloud is negatively charged. And this buildup of negative charges is what begins to pull on the ground positive charges from objects on the ground to connect with the cloud above. And as a result, the tops of the highest objects like trees or churches, they are affected by the buildup of negative charges sort of leaking out from the bottom of a cloud called a step leader. And as those negative charges begin to lurch towards the ground, positive charges begin to flow up from objects on the ground. Obviously, the highest point on the ground is obviously the object likely to connect. And if the positive charge is leaving the top of a tree or a church steeple or a skyscraper, if those positive charges connect with the negative charges, we actually see lightning as actually the negative charges drain down to the bottom and the positive charges move up. And the whole point of the movement of electricity you see is to basically balance out the differences of charges between the cloud and the ground. And the lightning we see going up is the lightning we actually see is actually the positive charges following the negative channel of charges that were coming down going up. So the lightning we see is actually going up from the ground to the base of the cloud. And this is a fascinating part about understanding lightning. These kids right here are a perfect example of the positive charges leaving the top of their head. They would be invisible, but their straight long hair is actually tracking the positive charges leaving their head. Obviously, by the visual expression, they have no idea that they're in imminent danger as these positive charges are moving up. that tells them that there is a thunderstorm overhead with negative charges, and those negative charges are getting closer and closer to the ground. If the positive charges actually from the top of their head does connect, they will be the conductor connecting the ground, which has a buildup of positive charges, and the negative charges above in the atmosphere. And obviously these two kids have no idea of how close they are to being struck by lightning, and I do believe the legend is that these two kids, I think this a girlfriend took this picture of her boyfriend and her little brother, and I think the story goes that these two kids were actually found, and everybody in the picture, I think there might even have been some deaths involved, but they were eventually found by some rangers, and they found them and they developed the film, and this was the last exposure, which we were, I think, are to assume was they literally caught a picture right before they were struck by lightning. I'm going to skip through these steps here, and I would strongly advise you to do a Google search on how lightning works in like YouTube, and watch some excellent videos of the specific steps of leaders, strokes, and flashes of how lightning works. I think this would be a very good review for you, and it's visually fascinating. And there's some examples you could put in YouTube, like human-induced lightning, where we understand lightning so well that we actually can control and actually initiate lightning strikes from thunderstorms from research labs. And so human-induced lightning or steps of lightning strikes would be an excellent review for you to watch on YouTube, for you to get a visual understanding of the different processes of a step leader and the return stroke and the actual lightning we see. And I would advise you to do that. And I'm going to skip forward from all the different types of fascinating issues with lightning, but I'm going to go right into understanding thunderstorms. Thunderstorms are obviously the main culprits here for us to understand where they occur and why, and they basically are the home of where we see severe weather, in particular severe thunderstorms and tornadoes, and that's what we're building to understanding here. Thunderstorms basically are like human beings that go through life cycles or stages, and understanding these stages give us the ability to predict where they are, what stage they are, and are they likely to produce severe weather like tornadoes. So I'm going to go ahead and go to talk about the cumulus, mature, and dissipation stage of thunderstorms. And this graphic is absolutely really fascinating to show you that air mass thunderstorms are generally driven by pockets of warm maritime tropical air that are being lifted up, often due to convection. And maritime tropical air lifts up in the developing phase, and that's what begins to build a cumulus cloud up into a vertical extent. And so this cumulus stage cloud is not a severe thunderstorm yet that could produce dangerous weather, but it is a developing thunderstorm. And we often call this atmospheric instability, where we say pockets of warm air, and this is, we got to have maritime tropical air, and this is the tie to chapter 9. We got to have maritime tropical air on the ground, and we've got to have some way of lifting it up. And often with air mass thunderstorms, it's just that the ground is hot and it's convectively lifting up, and as the cloud begins to condense, it releases more heat. The big key of a mature thunderstorm is its appearance. And a mature thunderstorm, this is where we see the classic anvil head, where the cloud is, the cumulonimbus cloud has developed, and we have a very strong updraft of maritime tropical air. The air has hit the top of the troposphere and is flattening out because the stratosphere sits above it and is producing a cap. And then as water droplets begin to grow due to the Bergeron process, we see heavier cloud droplets falling down in the cloud, beginning to produce either hail or rain. And it's at this stage where we likely see mature thunderstorm developing a tornado on the back southwest corner of the mature thunderstorm. But when we have a mature thunderstorm, we clearly see strong updraft and a well-defined downdraft, and this is where we see hail and precipitation on the front side of the storm. This is where on the downside of on the back side of the storm we see well-defined updrafts. And then what eventually kills a mature thunderstorm is effectively when a mature thunderstorm gets cut off from its updraft, the only motion left is the downdraft. And this is basically as a cloud begins to lose its moisture and heat, it begins to lose all of its energy. And this is the dissipation stage as a thunderstorm begins to lose its energy and punch. We call this a dissipation stage. Now, well, obviously, it's the mature stage of a thunderstorm that is really what we're most interested in for some of the other discussions. And there are other ways of producing thunderstorms that we'll discuss in sections and videos 2 and potentially 3, depending upon the second video. So I'm going to go ahead and stop it here. I don't like to go beyond 10 minutes, but I will start the next. I want to show you the next slide where we get into the classification of severe thunderstorms, and that's where we will take off with the next video.